Good thing we're already done with those lecture notes because Franklin has taken them for his own. Hi, welcome back. So in this section of our video, we're going to talk, this is part 2 of section 12.1, indefinite integrals. Now, when I introduced in part 1 the idea of integration or anti-differentiation, and we talked about integrals, it's not clear why they're called indefinite integrals. Later we're going to talk about something called definite integrals. Those will show up actually in chapter 13. So all of chapter 12 is all about indefinite integrals. The biggest difference is that there will be some numbers on that long stretched out S, but you don't need to worry about that now. Just know that we're talking about indefinite integrals, but you can just call them integrals. Okay, so in the last part we talked about what an integral is, what an antiderivative is, and we talked about how to find an antiderivative, but we did not talk at all about why we might care about these things. So in this part of our video, I want to talk about an example of why we might care about an antiderivative. And this is just one example. There are quite a few different examples that we will see over the next few class periods. So in this example, we have the monthly marginal cost for a product is MC equals X plus 30, and the related fixed costs are $50. Our job is to find the total cost function for the month. Okay, so the information that we are given that the marginal cost is X plus 30. And you might remember from before exam 2 that when we talk about marginal cost, marginal revenue, marginal profit, what we're really talking about is the derivative. So marginal cost is the derivative of cost. So what we're really given is we're given that C prime of X, in other words, the derivative of cost, is X plus 30. And we are told that the fixed costs are $50. And when we talk about fixed costs, what we're talking about are the costs for things like renting the building, the cost for paying employees. These are things that you have to do whether or not you actually produce any product. And so when we talk about a fixed cost of $50, this is the cost that your company will incur before they produce even one item or one unit. So this is the cost of producing 0 units. So the cost of producing 0 units is $50. That's what we mean by fixed costs. Okay, so this is the information that we are given, and our goal is to find a formula for the cost function. Okay, so here's an example where we're given the marginal cost, we're given the derivative, and we want to find the original function. Okay, so here's what we can write down. The original function must have been the antiderivative of the marginal cost. So if I start with the derivative and I want to go back and find the original function, I take the antiderivative of the derivative. Okay, so for us, what that means is we have the antiderivative of X plus 30 dx. So if we can evaluate this integral right here, then we're going to come up with a cost function. All right, so our rule for finding an antiderivative says when you have x to a power, you add 1 to the power. Now, in this case, this is like x to the first. So when I add 1 to the power, I now have a power of 2. So we add 1 to the power and divide the number in front by the new power. Now, there is no number in front, so that's an understood 1. So we divide 1 by the new power. So we have 1/2 x squared. And then we have a plus sign. And the antiderivative of a number is write down the number and tack on an x. All right, and then we have plus some constant. So we have our cost function is 1/2 x squared plus 30x plus c. Now, our cost function is named c, and c is standing for cost. So this c over here is not the same as our cost function, so I'm going to change that c into a k and spell constant with a k. That's okay. I just need to have some kind of a letter over here that maybe isn't the same letter as the name of my function. Okay, so here's our total cost function, but we have this plus k at the end because when we found our antiderivative, this is a function whose derivative is x plus 30, but we don't know what that number is on the end. So we still need to figure out a value for that k on the end. And the way that we do that is we go back and we look over here and say, okay, what other information do I have? And the other piece of information that I have is that our fixed costs are $50. In other words, when the company produces 0 units, it still costs the company $50 per month. So we're given, or we are told, that when x is equal to 0, our costs are $50. So when we produce 0 units, the total cost is $50. So I can use this information in my almost finished formula and see what happens. So our costs are $50, and here's a formula for cost. And if we plug 0 into that formula, we have 1/2 times 0 squared plus 30 times 0 plus k. Okay, so this says that when we plug 0 into our cost function, we'd better get out $50. Now, if I clean this up, what I have is that 50 is equal to 0 plus 30 times 0, which is 0, plus k. And that tells me that in this example, that plus k at the end is going to be 50. And so that information tells me that my total cost function is this guy up here, but now I know what the k value is. So our total cost function is 1/2 x squared plus 30x plus, we found out that k was 50, so plus 50. And so now we have come up with our total cost function. Okay. So we've answered the question, which was find the total cost function for the month. And here it is. One question that you might have is, well, Diane, it's super convenient that that plus k up there just so happened to be equal to your fixed costs. Is that always going to be the case? And the answer is sometimes yes, and sometimes no. It depends on how complicated the original cost function is. When you have more complicated cost functions, then sometimes that plus k does not end up being just the fixed cost. So we have to be a little bit careful about that. So be aware, do not always assume that that last plus k is going to turn into the fixed costs. Okay, that's it for this example. Thanks for listening.